Okay, so previously we looked at what happens when x tends towards infinity or negative infinity. Now we want to look at what happens when we get close to a value that makes the function go off towards infinity, or from our pre-calc stuff, we refer to these as vertical asymptotes. Right, you can see one on the graph here. And this is the graph of negative 2x, x minus 3 to the third. And we're going to look at the left-hand limit, the right-hand limit, and see if we can take the limit in general. And so once again, you can look at the table on your calculator. You can try to come up with a pattern of, are the numbers getting bigger and bigger and bigger, smaller and smaller and smaller and smaller. Be careful, if they get really big, your calculator is going to do that scientific notation thing again. So just be aware of what really big numbers and really small numbers look like in scientific notation. But another way we can look at this is on the graph and just kind of trace it out or follow it. So if we're taking this one, the right-hand limit, how do I know it's right-hand? Because it's 3 plus, meaning 3 from the positive side, right? So if x equals 3 is like here, we want numbers slightly bigger than 3. So as we come along on this graph, right, from way out here, the closer we get to 3, the function value, or the graph itself, appears to be getting smaller and smaller and smaller and smaller, right? So the closer I get to 3, and you can kind of see it in the behavior here, if you pick a number bigger than 3, like 3.00001 minus 3, you get a really small number. You're dividing by a really small number. That's going to fit in there a lot of times. So it looks like, and we can see on the graph, that this is tending towards negative infinity. All right, so then on the other side, if we come at 3 from, pick a different color just for fun, the negative side, so numbers like 2.9, 2.9, 2.99999, right? We get closer and closer and closer from the left-hand side, so I'm just following the function. So it gets bigger and bigger and bigger, and so it looks like on that side it's heading towards positive infinity. And then if we talk about the limit in general, right, this isn't a one-sided one. Remember, both sides have to agree. And since the left-hand side is going up and the right-hand side is going down, right, one of them's going towards infinity, the other one's going towards negative infinity, then we can say that this one does not exist, or if you like abbreviations, DNE for does not exist. They have to agree on where they're going for the limit in general to exist. So you can have a right-hand one and a left-hand one, and if you ask about the limit not one-sided, it does not exist.